Hello and welcome. Here we are in lecture two, which is, technically still part of the first class session. Um, so we will be talking about actually getting some chisel running. As I said, close the loop early, right? That's that logo keeps showing. And so yeah, today we'll be getting a little bit of chisel running. Because of the splitting the lecture in half, technically we'll be only getting Scala and we'll do the chisel next time, but we'll get some code going. And so you may have seen me a second ago fumbling around over here. Right now, I'm running this off my laptop, but usually for this lecture, I also try to run it from the cloud to show you it's possible. So yes, our lecture slides are not just open source on GitHub. If you don't want to install Jupyter, which trust me, it's a bit of a pain at times, you can run it on the cloud. There's a service called Binder we have set up such that you can just run that and it'll let you run it on the browser. The caveats to Binder is a couple. One, if you leave it idle for too long, it'll just kill your instance. So if you're doing a lab, for example, and you go off to get a meal and come back, it'll be dead. So make sure if you're doing labs to save it. Um, the other catch to Binder is sometimes the first launch is slow. And so I usually try to make sure the first launch before lecture, I do that. So I have to wait 10 minutes for it to build the image. But then for everyone else, it's faster. But if you see a 5-minute build time, that's not unusual, and then it should be fine. But yeah, if you want to run Jupyter locally, we have information on how to do that yourself. We also have a Docker file contributed by a former student. So great. Go ahead and play with this code. Um, so what are we going to do? Well, as I said, with the split in half for today's lecture, we're going to do mostly brief taste of Scala. But in the expanse of this full hour lecture, yes, you would see both brief taste of Scala, brief taste of Chisel, and then close the loop. And that's kind of philosophy of this course, where rather than learning, everything there's to learn about Scala, everything there's to learn about Chisel, and everything there's to learn about hardware design, we give you tastes of all three, right? We give you a little bit of Scala, a little bit of Chisel, a little bit of hardware design. Then we want to be more sophisticated. Okay, do we need a little bit more Scala, a little bit more Chisel, a little bit more hardware design? Kind of keep building our way up through these various components. Cool. So we talked about Scala's a few minutes ago. What are the main features of this language? As I said, it's in the Java family. It runs on the Java virtual machine, which is great. That means you can pull in any existing Java code and link against it and code it. And so that's really helpful. You can imagine building a really cool generator, for example, that maybe your generator gets the parameters and needs to run from a database. Maybe it can read, a JSON input or something, whatever you want to do, right? All that stuff that's out there in Java, you can do. And as I mentioned before, I'm a high performance computing individual, so I'm all about speed, but I have so much respect for the Java ecosystem, right? Because there's so much correctly operating code in the world running on Java, right? So to diss Java is to diss working code, which is, wrong, right? So that's why it's out there. In terms of what makes Scala specifically useful, it's object-oriented. So Java, of course, is object-oriented. Scala embraces that, adds some more object-oriented features on top of it. Has a very strong static type system. It also has type inference. But unlike the original Java, but now modern Java has some flavors of this, it has support for functional programming, right? And that's going to be really helpful. And for those of you that's not familiar term, don't worry. You will see that covered in this course. I try to make this course inclusive. If you're more from the hardware background, you aren't familiar with functional programming, don't worry. We will cover that in a very empirical and practical tone in this course. Um, One thing that takes a little bit getting used to with Scala, if you've never seen it before, the language's goal, and if you hear this from this creator, Martin Odersky, who watches videos, is to try and catch as many errors as possible at compile time, right? They want to, rather having some sort of, subtle logic error you got to debug and figure out, they want to turn as many of those as they can into compile time errors, right? Remove that chance, remove those issues right away. And so this is why I was recommending earlier when writing Scala, I really recommend a tool like IntelliJ and full IDE because it'll do things like underline, compile errors as you write in the code, tell you right away, you know what, this is not correct syntax. Let's just build this right now. For those of you who really love to use VS Code, there's something called Scala Medals, which is a way to get a language server that can kind of give you some of those IDE-like features inside things like VS Code. And there's links for all this on the webpage if you want to set this up. So why did Scala get selected to build Chisel? Um, the reason why was Chisel was a domain-specific language, right? They wanted to build a new language for hardware design. Writing completely from scratch syntax parser that seemed overkill, and so they wanted to embed an existing language, and Scala was made to make embedded languages, right? Embedded DSLs. And so some famous examples are, of course, the Light project at Stanford built a lot of things in it. Um, at Berkeley at the same time, there was, of course, the Spark project, which, of course, gave birth to Databricks. And so, yeah, when Chisel was created by researchers, This was available, and it was great. There are other hard description languages out there. There are these new modern ones that are embedded DSLs that use other languages, right? There's Python-based ones like PyMetal or PyRTL. Um, there's a few other ones out there. There is, I'm just trying to name off the top of my head. There's so many of them. There's things even in Dash like I can't pronounce this, OROHD. There are languages in Haskell. There are languages with Clash, right? There's all sorts of hard script languages out there in the modern era. Chisel is kind of this, you know, flag bearer of this new generation from about 15 years ago. And so why is this so useful? Well, with Scala, all these nice programming features, we can build really nice generators. They're really robust code, really flexible code. Um, that's the whole point. We're trying to build these generators to get productivity. And it turns out when you start writing Scala, you'll find that actually it's, core set of types and its basic standard library is actually amazing. The collections it provides and actually all the functionality it provides in these collections is really, really helpful. A lot of things you want to do, it's just there. Um, so yeah, it's kind of fun. So when you're actually running Scala, there's two ways to run it. The normal way, you write code, hand off to the compiler, and let the compiler do its normal things. The standard compilation, execute that. Technically, what that's doing is it's turning your Scala program into Java bytecode, which then runs, of course, in the Java virtual machine, the JVM. So when you write code in this manner, not unlike Java or anything else, you have a main function, and you actually don't usually use the Scala compiler directly. You usually use this tool called SBT, which is kind of like a combination package manager and build tool to actually execute and compile it. So SBT is kind of the classic Scala build tool. There's a new one called Mill, which is getting a lot of traction. Uh, these distinctions are often hidden by an IDE. So, for example, if you're using something like IntelliJ, you set IntelliJ up, you don't have to worry about this. Um, this is normal, right? And this is what you can do for your bigger designs. But for things like lecture or our labs, we actually take advantage of Scala has in their execution mechanism, which is the interpreter, or sometimes referred to as the read eval print loop, or REPL for short. So that means you can write one line at a time and just see what happens, right? So you've seen this in Python. If you're familiar with Python, you've seen how you can write entire Python programs across multiple files, or you can just start messing around on the Python prompt, right? Scala has a REPL, has a prompt. And that's really, really helpful. If you're just trying to figure out one feature or one little bit of code and want to play around with in isolation, it's really, really helpful. And so Scala provides that, and we're able to use that functionality to do that inside of these Jupyter notebooks, right? So these notebooks, when we were running the course, these are embracing this, REPL style execution. With the REPL style execution, you don't need a main function. You can just write lines of code and they run. There's a tiny fraction of legitimate Scala you can't write in the REPL. It's not because the REPL is broken, it's because of Almond, which is the Jupyter environment we use, but it's a very small subset. Cool. So let's actually try writing some Scala code. And if you've seen language like Java, it'll of course be extremely similar because it's a language scheme out of Java. So of course we can have, things like integers and do math. We can have things like a floating point number, or we can have a string, right? So if I go ahead and evaluate this, um, sure, we can see, yes, we add two numbers together. We get not just the result 5, it's telling us the type is int, right? So this is the case where it did type inference. It inferred that these two operands were integers, and so thus the result of integers is going to be another integer. In this case, it did type inference and saw, oh, there's a decimal point, so that's going to be double. Even though it's operating an integer, in this case, the Scala type inference decided, double interacting with an integer is double. And of course, here at the quotes, that tells it it's a string, right? So these are all inferred types. Now, a few things to note. Number one, there's no semicolons, right? So these are 3 separate lines. Scala is clever enough to kind of figure out where lines end. So we basically never use semicolons. It's nice. However, unlike a language like Python, indentation's up to you, right? You're not forced to do a certain white space in a functional sense, right? It's just white space for human readability. And so, yeah, language is such that the parser is able to figure out each statement, each line on its own pretty well. And so it's nice. It's this very clean, pretty syntax. Another interesting wrinkle is that some languages have a notion of primitive base types versus object types. Scala simplifies that. Everything's an object. So even like the integer 2, that is a capital I int, right? That is an object. And so it's kind of simple, right? You don't need to think, is this an object versus primitive type? everything's an object all the time, and so as objects, they have things you can call on them, right? So, for example, if I was to, yeah, we'll see some examples in a second. Um, Questions so far? Cool. Okay, so in the last slide, I kind of told you about the type inference a little bit. Let's kind of flesh it out a little bit more. So I said everything's an object. Um, and because it's a statically typed language, that means at compile time, everything must have a definite type, and these types must be compatible in the way that they're interacting. Now, to make the language more easy to read and write, it has type inference. So not everything all the time you need to specify the type. A lot of times you can omit it, it'll infer the correct thing. And that's nice. Now, so for example, like we saw before, okay, yeah, number 4 by itself. We saw in the prior slide that's going to be inferred to be an int. Now, when you want to specify types, you put it after the thing. So in this case, these are all literals. If I declared a variable name, the type also goes second. It's a little bit one of the few places where syntax is a little bit different. Maybe you've seen languages like C or Java. But yeah, so the type goes afterwards when you annotate it. Um, what's interesting is even though number 4, of course, you have 4 isn't by itself. We can remind it 4 is an int, and even though it was already inferred to be an int, no worries. By annotating these other types, it's also possible, right? So we can go ahead and evaluate this. Sure, right? It was inferred to be an int, I'm sorry. And in this case, we said it was an int directly. In this case, we said it was to be a float. We said it would be a double. In this case, said it was a character. And because this is an object, we can call methods on it, right? So we can call toFloat, right? I can, see what else is available. And there's a whole bunch of, methods built into object, right? It's kind of like, wait a second, it's number 4, but yeah, it's an object, even though it's literal. And so you can see there's some variety of methods already available there. And here I'm running inside Jupyter, inside all these things. This completion is there. I will note the font is a little bit smaller in today than I intended. I'm going to figure out resolutions in time for the next lecture. But yeah, these are live, real things. Cool. Questions so far? This is the first taste of Scala. Like you said, in my opinion, it's a very pretty language. Um, cool. So let's actually declare some variables. So what's interesting is Scala has 2 types of variables, 2 classes of variables, just say, right? You have mutable variables and immutable variables. The variables themselves are the same size in memory, they're the same thing. It's just a matter of what permissions are you giving people. If you declare something as a var, that's a mutable variable, meaning it can be changed. Conversely, if you declare something a val, that is immutable, right? So val is like const in many languages. What's going to surprise you is the vast majority of the code you write will use val, right? You will mostly write things where you assign a variable once, and that is it. This is kind of in that functional philosophy, where you may have seen a lot of functional languages have only write once semantics. Guess what? If you're using val, it's write once. If you try to change the contents of a val, it's going to yell at you. And so the question is, well, of course, why should we work so hard to embrace this write once semantics? Why should we work so hard to embrace immutable variables? Helps in a variety of ways. Number one, as a performance person, you tell the compiler this thing is not going to change. The compiler can just go much more aggressively about optimizing it, right? Understands, wait, it's not going to change. This is this. I can do this and this. You're giving a lot more stuff there. But it also helps you avoid mistakes, right? There's a variety of places I'm going to show you in this course where I'm going to discourage you from using var. And I'm going to show you, if you use a var, there's a way to have typos someplace else to actually have a very subtle, hard to find bug. If you use vals, you can just eliminate entire classes of bugs and all that time spent debugging. Additional advantage of using val is that by having write once semantics, you have these kind of single purpose variables. Sometimes this is much more common in people who are first learning to program. They make a variable and they keep reusing the variable. And so the variable, what it means, kind of changes over time, right? Like, oh, in this case it means this, in this other case it means this. And it's like, that's really hard to debug, really hard for someone else to read, right? So by having this write once semantics, you're forced to kind of say, you know what, this is the purpose of this value, and I'm not going to change it. And you have more descriptive names, has single purpose, it leads to much more clear code and much more easy to maintain code. So let's see what happens if you try and declare some of these, right? So for example, here we have, one of these mutable variables, var, and I labeled it mutex, great. It initially has the value 0, but later on I assign it 2. Meanwhile, this const is a val 42. So for example, if I didn't declare this a val, instead declared it a var, or sorry, didn't declare it a var, instead declared it a val means, making it immutable, the compiler's gonna yell at me, say, hey, you can't do that. That was supposed to be, immutable, and you reassigned it. Um, and so yeah, in this course, you're gonna see me basically almost never use var. A lot of students when they hear that, you can do more things with var than you can with val, like, oh great, I'll just use only var. And I'm telling you, no, 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 no. Not only should you use val basically everywhere, or just about everywhere, when it comes to things like the project, we do look at your code. And yeah, frequent use of var is a big point deduction, right? So use val. It'll make life a lot better for you. Trust me, it'll save you time. And there'll be a few times, you know what? Maybe you find you want to use val, and there's a situation like, you know what? I just have to change the value of this variable. It's the common challenge of functional programming is how do you always do right one semantics? Functional programming has typical ways of getting around this, things like recursion, other techniques. We'll look at those in this course. In a handful of those cases, caving using a var, in my opinion, actually will be simpler code, but that'll be a handful of cases rather than the common case. The common case, use val, try to use it whenever you can, and only if you really, really are in the corner, consider var. But even then, like I said, you can do the entire course all with val, never use var, and you could write great code. So please, please, please use val. Questions? Cool. Okay. So let's see how we're doing on time. I do want to have a 50-50 split on this lecture for next time. So I think I'm going to pause here if there's no other questions. And we'll pick up this lecture midway on Thursday. Okay, I'm going to stop the recording. I'm still available, both Zoom and in person if you have any questions about the course.